All right, today is January 29, 2025. This is the meeting of the Container Storage Interface Community. As a reminder, this meeting is public, recorded, and posted on YouTube. On the agenda today, we've got quite a few items. We're going to start with this one from Neil. Neil, you want to give an intro on this?
Yeah, sure. Hi. So I'm working on the CSI driver, and we would like to give our users better indication on how much of the volumes is still available or used. Um, this is mostly important for block mode volumes. So volumes with the file system, we can get metrics quite well, but for block mode volumes, we cannot inspect the contents of the block device. And for that, we can request the Ceph cluster um, how much data is actually allocated for such a volume, because usually they're sparsely allocated. That gives the user an indication how much data they can still write, for example, in their VMs or any other workloads that uses block volumes. For contacting the Ceph cluster, we need the credentials in the node get volume stats RPC call. Currently, this call does not have any credentials, and this request has been opened in 2019, so it's open for quite a while. I would like to see what it takes to make progress there. I'm happy to work on the Kubernetes side
So
of things because I think that's where the difficulties lay.
before we get to the topic about the secrets, just on the specific issue, is there not a controller get volume stats that we can use? I can't remember.
I
I'm looking right now.
don't think so.
Uh, does anyone remember?
Yeah, I think it's only on the note side. Good one
Okay,
is
so it's okay. So it all the call always goes to the node. So any secrets that the controller has, you can't get access to. If you need a secret, it must come from kubelet, which means it must be a Kubernetes secret. Okay. Yeah, so the basic issue here is that as we've designed CSI, like we sort of add secrets on a per RPC basis. And then the way that's handled on the Kubernetes side is that like we have this ever proliferating set of secrets per volume, which is getting ridiculous at this point, right? The obvious answer here to solve the specific problem is, oh, just add yet another secret that kubelet can pass to this API through some secrets field. The problem is that like this approach clearly isn't scaling, right? Having a secret per RPC. I think in the bug that was referenced, there's a link to an old discussion where we said, you know, what we should have is a more comprehensive way of specifying, you know, a small set of secrets on the CO side that can, and then some mapping that defines how those secrets get passed to different RPCs so that it's not just every single RPC has its own secret, right? And we kind of need to solve this problem mostly on the Kubernetes side more than the CSI side, right? Because the CSI just says there's a secrets field and the CO passes in some stuff, and it doesn't specify how the CO is supposed to handle this. In Kubernetes, we initially decided to have separate secrets per RPC because I guess that was convenient. But I think in retrospect, that was the wrong decision. And we don't have any good guidance on the CSI side on how to improve this. So I don't know. I'll stop talking and see does anyone have any ideas to try to unify this and make it better? Or are we sort of at square one?
Sorry, I missed
All right.
the beginning of the call. So,
Oh, hey, Emma.
sorry.
Yeah. So there's a specific request for Ceph CSI where they need yet another secret for the node get volume stats API. And I was saying like we could just add another secret, but like the proliferation of secrets that we have to manage on the Kubernetes side is getting out of hand. And it would be, and there's an old bug that's like 5 years old that sort of references this problem. And it would be nice if we tried to have a comprehensive solution for secret management related to CSI volumes.
Yeah. Yep. So in this case, like the Ceph has a use case where, like, originally we added this to basically just get the how much disk is taken and blah blah, how much is disk is available, how much disk is taken. Then we added volume health to that, and that probably added a requirement of talking to backend. So
Yeah.
when we so that's
I mean,
what
the problem is we discover with every single CSI RPC, somebody wants to talk to something that needs a secret, and we always end up needing to add a secret to every RPC. And
yeah.
so rather than continuing to do it piecemeal, like we need to address this at the CSI level and say we're going to have like a way to pass secrets in that's consistent across all the APIs. That's what's necessary, I think. But I don't know what that looks like. I just know that what we're doing is not going to scale.
It means in Kubernetes side, the PV object will have like like I don't know, 10 different fields. Already it has node
Well, I
ex
mean, we need to be backwards compatible, obviously, with what already exists. But instead of just adding more and more and more, I feel like we should add like one or two more secrets that are like the last secrets that are going to be reused everywhere, right? And the problem I point out in the bug is that it's not as simple as like just having like the secret for the volume, because it is the case that some drivers do require different secrets for different purposes. And the case I pointed out was some volumes have like an administrative secret, which is required to talk to the back end and perform operations in the back end, and a second encryption secret, which is user controlled and used to perform encryption. And it tends not to be transmitted to the back end, but is handled locally. And you wouldn't want to mix those up, for example, but you would want to handle them consistently across RPCs if you had them. And today it's all just ad hoc, how that works. Right.
Yeah.
So like in my and this is very fuzzy, but in my imagination, I was thinking of just like some per volume secrets that are defined on the Kubernetes side, and then some way of instructing kubelet and the sidecars for how to like which secrets should be sent to which APIs, rather than just directly pulling from all these separate secrets. Like just say, okay, look, these are my two secrets for my volume. Send these ones to these RPCs and send these ones to those RPCs. And as we add more RPCs, we can just, scale it and say, okay, use the same secrets now for these additional RPCs. So we don't have to just keep adding new ones. And I think that would address Neil's requirement if we had something like that, but we don't. And it's a more significant change to add that than just continue doing what we've been doing and keep adding more, per RPC secrets.
Yeah. If we added this hierarchical, like some sort of like a list of secrets, then it will also mean that we'll have to have like define them, but what is the capability of all those, what are the permissions associated with those secrets are, and it will, yeah, it will be get
But that would all be on the CO side, right? CSI doesn't specify any of this. It just says the CO needs to pass in some secrets, right? So like we can in principle solve this entirely on the Kubernetes side,
Uh,
with the exception of like the RPCs that don't even have a secrets field yet.
but how do we pass that to the backend if we don't have that field in the RPC? What is the way?
No. I mean, so the proposal would be like we add some language to the CSI spec for existing and future secrets fields that says like the CO should do something so that the same secrets can be reused across all RPCs, and then we can just spell it out and say, and then we can add secrets field to existing RPCs. But what we don't want to do is just keep adding one-offs, right? New
Okay.
secret here, new secret here, new secret here, and leave it up to the CO to do whatever, because the result of that has been we have like 10 secrets.
So you're basically saying like we should use one secret per volume, and then that's for all the costs, for all the.
Well, and not necessarily one, like it could be two or it could be three. Like there is room for multiple types of secrets that are used for different types of things, but it should be a small fixed number defined by the SP, and they should just be sent to all of the RPCs in a consistent way.
So Neil, can you spell out like why does the Ceph need this? Just sorry, I,
Right.
I
Yes, so that's what you missed. We want to call the RBD disk usage operation, which requires connecting to the Ceph cluster, and it's mostly for block mode volumes. So for file systems, it's less interesting because you can get the file system metrics, but for block mode volumes, we want to know how much the block volume is actually used. So the RBD image is actually filled with data, and how much is still sparse.
and this information is not available like on standard like stat or DF.
No, you can only attach a block device. You get the device nodes and you can get the size of the disk, but that doesn't tell you if the disk was sparsely allocated or thin provisioned.
Yeah,
And
you would need some kind of like proprietary SCSI inquiry to or something like that to inquire like how many blocks were non-zero, right? That's not a standard Linux thing that you can ask a block device how many blocks are non-zero.
Yeah, especially for I think for raw block devices.
exactly, yes, yes, it's only for our block devices that we need it. But as you mentioned, for volume health, it might be something useful as well.
So anyways, I guess the big question here is like are you willing to like help work on a design and do the implementation to try to solve this at the CSI level? Or are you only interested in just solving the specific problem for Ceph, and not contributing to like a larger
so
secrets
we need
management
it for Ceph, but it's a long-term thing, and I'm definitely willing to help
Okay,
designing it.
because I think what we need to do then is work on a proposal to try to make it so that in the future, as we add RPCs, we don't just keep repeating the pattern of separate secret and sidecar.
That makes sense.
If we can write that down and figure out what the changes would be on the CSI side, which would be very small, I think, just some text saying like you should do it differently. And then the big change would be on the Kubernetes side, changing kubelet and changing the sidecars to have a more consistent way of handling this. If we can get that written down and then have everyone look at it and say like, yeah, this seems like it would work. Then it would just be a matter of, approving that and submitting some CLs or PRs to get it changed.
Yes, I can definitely work with that. I'm not so familiar how Kubernetes currently passes the secrets, so I'll need some guidance there, but I'm definitely willing to take this
Okay.
on.
Okay. Well, yeah, maybe we should follow up offline and I can try to help you find like I don't remember off the top of my head where the docs are on how to configure secrets, but I know that like you end up with a bunch of annotations on your PVC with like the names of all of the secrets.
No, sure.
Um,
Yeah, just some
and
pointers
and
will be fine. That's
and
good.
that's the thing that we would want to change is to stop
Yeah.
doing that.
Mm-hmm. No, I understand. That sounds good.
Okay.
All
All
right.
right. So yeah, go ahead, Saad.
Yeah, I think we've got a conclusion here. So sounds like we're going to try to come up with a holistic solution focused on stopping the proliferation of secrets on the CO side. So we'll come up with a holistic solution that prevents the proliferation of on-off CSI RPC secrets on. Okay,
All
let's.
right. And then
Next
The
one.
next
Yeah, go ahead,
topic
Ben.
was also Neil. The next topic was Neil,
Okay.
interest in changed file tracking. I assume this is a reference to the changed block tracking.
Yes. So at IBM there is uh, there's a team that uses the change block tracking or wants to use the change block tracking, and they are asking for change file tracking if it's
Yeah.
something that
Yeah,
becomes
so
available. And ZFS can do it quite efficiently, but we don't
cool.
have the interfaces in
Yeah.
CSI spec or in Kubernetes. So there's a request if we can enhance these components to add
Yeah.
changes file tracking.
I would encourage you to come to the data protection working group meetings and discuss this with the people who are actually doing the change block tracking stuff. I can tell you from the history of this, when we started the whole change block tracking, what, I don't know, 3-4 years ago, it's been a while. We talked about both. We talked about change block tracking, we talked about change file tracking, and the consensus among the group was that change block tracking is more widely applicable and is the right thing to start on. And it's probably fewer vendors would be able to do change file tracking, but it's still something we would want to pursue eventually. And if the change block tracking model works, and so far it's been going well, there's no reason we can't come back and do a similar thing for change file tracking. We just decided to tackle one at a time because it's so much
Oh, of
work
course, yes.
to do anything.
Yeah, no, that makes sense. Yeah,
And,
thanks for
and interestingly, you know,
the feedback.
I come from NetApp, and when I was at NetApp, you know, NetApp actually has the change file tracking APIs as well. They do not have change block tracking APIs. So I've been wondering how NetApp is going to handle the change block tracking stuff. I'm not there anymore, so I don't know. But change file tracking is definitely interesting.
No, exactly. So ZFS can do file tracking and ABD can do block tracking. Block tracking is something that we have now mostly. So the next thing is file tracking.
Yeah. Okay. So
Good.
I think the right
Thanks
way to
for the
proceed
feedback.
is as an addendum to the change block tracking proposal, and the right group is the data protection working group. Come to those meetings and talk to those folks and see how much help we can get to push that forward.
I'll do that. Thanks.
Cool. Thank you, Niels. Thank you, Ben. Let's move on to the next one from Sunny. Sunny, you want to talk through modify volume returns topology?
Yeah, so like I think Alibaba Cloud has a request that after they modify volume successfully, like the topology of the volume will change. So they want a way that the modified volume can return a new topology.
Yeah, and Sada, you probably know more about topology than anyone because you were involved with that feature. My understanding of topology is we designed it in a way that's basically static and not changeable, right?
Yeah, the original intention was that it's supposed to be immutable. I think we can revisit that to see what assumptions break if we make it mutable.
Yeah, I'm kind of nervous about that because the allowance that we made because it was mutable was we added the feature on the Kubernetes side to do late binding so that you could wait to create the volume until after the workload that would be using the volume is scheduled, and then you could provision the volume close to it. But yeah, the end result is you end up with a volume that is an immutable topology.
Yeah, because I
So
think part of the process was basically when Kubernetes loads a CSI driver, it kind of interrogates the driver to understand what, the topology characteristics look like. And then as it discovers volumes, it uses what the volumes are saying to map that back to the characteristics it discovered for the storage system. So as long as I think the storage system characteristics don't change, but only the volume characteristics change, it may be possible, but we really need to kind of think through the edge cases here.
But does that mean for modified volume, the Kubernetes scheduler will be involved now? Because now you need to find a new node. Is
well,
that
Yeah, that's
I
a good
mean,
point.
Yeah,
The,
the use
the,
case provide that if it's online, online modified volume, they make sure that the new topology is compatible with the node.
yeah, the concern I have is if the volume is attached when you change its topology, like what does that mean? Like if the new topology doesn't match the currently scheduled workload, like how is that even possible, right? You could work around that by saying like you can only do this offline, but it'll introduce a bunch of new weird corner cases you have to sort through.
I think like do they have to use modify volume at all in this case? Like answer seems to be like in this case, if modified volume results in creation of modified topology, then PV object has to be topology. Obviously, it's has to be modified. The scheduler has to be get involved. It gets too complicated.
Well, I don't see how the scheduler is going to get involved because the scheduler is involved with workloads, and if there's already a workload attached, it's not going to move, right? It's the workload is where it is, and if you detach it and create a new workload, that was going to go through the scheduler anyways. So, like, it's just a question of can you do it online, and how do you handle the weird corner cases that would result from like a new topology that didn't match the existing workload.
Or can we just say if you do this, you have to make sure it matches?
Yeah.
You could say that, but someone will do the other thing. And then the question is, how do you handle it when they do the thing they're not supposed to do? Right? Is it an error? Do you kill the workload? Like just how are you supposed to respond when a driver violates the rule?
So two things by the way. So if modify volume results in change of topology, then like for something like stateful set, which will not schedule pod to a different node unless, like even if you delete the pod, it will schedule on same node actually. So unless like it will get complicated actually because the pod cannot run on that node anymore. And coming back to, yeah, what Sunny said, like what happens, like should we just disallow it? Like, okay, modify volume should not result in change of topology.
But that's how it is today, right? Nothing can change the topology. So I think on the Alibaba Cloud situation, like they have some older hardware and some newer hardware, and one of the modifications you can do is to say like take advantage of some new feature which is only available on the new hardware, which necessarily means the volume will now need to have different topology than it used to, right? If you're imagining like a hardware refresh in a cloud setting, um, you want to say, oh, my old volumes can now take advantage of new features that were not available when that volume was created, but are available now, and that requires their new topology.
I feel like I feel like this is like a gateway of doing volume migration via using. This is
But it's the same volume, right?
Oh, I think, yeah, modified volume could cause migration, right? Like we are actually going to implement this one because
Yeah, no,
the change to the
exactly.
policy caused the data store migration. But if topology also changes, then yeah, uh,
Well, but when we
that's
define modify
different.
volume, we didn't say that it was okay to make the volume unavailable for any length of time. Like the assumption is the volume is online through the modification based on the existing wording. I mean, of course, drivers can violate that, but the principle was modify was supposed to be for things that could be done non-disruptively. Um,
So we could
and
do online migration, but data store change itself can take a long time, right? But
okay,
but
yeah,
but
yeah. I
this,
mean,
yeah, but the
if it can be
topology,
done transparently,
yeah.
that's great.
In vSphere case, volume migration doesn't result in topology change. You cannot, even a CNS volume migration, you cannot do between topologies. So
It,
yeah, you
it,
can change the data stores, but it doesn't change the topology in which it was deployed.
maybe what's going on here is we're using the well it could be Alibaba in particular is using topology differently than how it was intended. Because my understanding of topology originally was it was supposed to be some geographical notion, like I have some servers in this place and some servers in this place, and the topology represents the fact that there's two places. If what you have is two different kinds of hardware, um, like whether the division between the hardware maps the geographical differences or not is sort of a separate consideration, right? Because what you're really saying is the modification of the volume wasn't intended to move it from one geography to another. It was meant to modify some feature of the volume. And it
Yeah.
may just happen to be that because of where your hardware physically is, you also have to migrate it to achieve that. So maybe what's going on is like this is not the right way to use topology. And this is the fact that the topology is changing is a side effect of choices made in a specific deployment. And what's really needed is more like a migration feature.
Yeah. So this is like, in my opinion, this is not a this doesn't come into the problem space of modify volume. It's a different feature that Alibaba is looking for and trying to get modify volume to work with it. And I do not want, at least I do not agree that we should implement this or just somehow make modify volume retrofit this thing. So yeah.
Yeah, I'm worried about all the cans of worms that'll be opened if topology was assumed to be immutable, and then we break that assumption. Maybe it is safer to say we should investigate a migration function, which is explicitly designed to change topologies of volumes, but to do so in a disruptive way. That's probably going to work better for most vendors anyways. If you're moving a volume from one, if you're intentionally changing the geographical characteristics of a volume by moving the data to another place, we should support that and say that's actually a migration, right? That's a new volume in a new place that just happens to have the same data as the old volume. So yeah, I'm leaning that direction, saying like let's try to solve this as a data migration case. Let's try not to break the assumption that topology is immutable and see where we get with that approach.
Yeah,
Because
like
I don't.
I think we should add data migration also meaning topology change, because like we can do data migration without violating the topology restriction.
What I no, I in my mind, data migration means you get a new volume, right? So just some sort of like create new volume from old volume, and the new volume gets all new things anyways, right? New storage class, new volume attribute class, new topology, and it because it's a clone of the old volume, it'll have the same data. And so from a user's perspective, like that's the right way to do a migration, I think. And it frees you up to make any changes you want as because you get a whole new volume.
Yeah, so I think what I'm hearing is it doesn't make sense to change modify volume to mutate topology. You could do a data migration today, which results in a new volume, and that lets you change topology however you want. But maybe it's worth investing in a migration feature that allows for an existing volume to be migrated to a new geography, but that should effectively be a new feature separate from modified volume.
yeah,
Yeah,
okay.
and
I will
I'm still
Okay.
nervous about that proposal to have an explicit migration feature because we'll have to think through all the weird corner cases of because that would involve changing the topology on an existing volume and therefore violating the assumptions that went into the whole topology feature. Makes me nervous.
Sunny, what do you think?
Yeah, that makes sense to me. But like, I mean, we have another case coming up that we want to change node affinity, but let's discuss it next time.
Yeah, I was gonna say we're past our time, unfortunately.
Okay.
If we don't want to wait 4 weeks, we could schedule a one-off maybe, or if people are okay waiting.
Sunny, if you're okay waiting, I'll put this on the schedule for our next meeting.
Okay.
Or do you want to schedule something one-off in between?
Yeah, maybe something went off.
Okay. Can you take the AI to set something up with this group?
Yes, sounds good. Who's interested? Like Shane and Ben, Hermand.
Yeah, you can add me, Michelle, and
Okay.
Ben and Jan, basically this whole group.
Okay, sounds good.
All right, thank you.
Thank
Thanks,
you.
folks. Good discussion.
Bye.